Welcome to class, everyone. In this class, we're going to be learning about combinations and permutations. This will be a review for some of you, but most of it will be relatively new. So let's start with the definitions of combinations and permutations. And just as a heads up, this will actually be my last class because the school year is starting and I don't have time to prepare the slides. So this is the last class. And let's start with the first definition, the permutation definition. Okay, definition of a permutation is a linear sequence or set in which numerals or symbols are arranged, and order does matter for this one. Okay, let's say, and here the definition states a set, right? So let's come up with a set of numerals. Okay, let's say there's 4, 3, 2, and 1. Okay, that's a set. And a permutation is a linear sequence in which the numerals of this set can be arranged, and how many or sequences there can be of this set, this particular set. Let's see. So we can do 3, 2, 4, 1, right? And 1, 2, 3, 4 even. But I mean, I could list all of them, all the way to the last one. But this is too slow, right? And you might miss one or you might repeat a few. And later on, I'll give you a strategy on how to find all the permutations for a specific set of numbers, okay? And then you can solve permutations very fast. But this time I'll just go over the definition and give examples. So next one is combinations. So the definition of a combination is a selection of items from a collection, such that, unlike permutations, the order of selection does not matter. And let me give an example. Let's say we have another set, okay? Another set. Let's say it's 1, 2, 3, 4, 5, 6, all the way to 8, okay? All the way to 8. And we have this set of numbers, 8 numerals. And from that set, we have to select a couple of items. So let's say, how many groups of 3 are within this large group of 8? So you have to, let's say, select a group of 3, and how many total groups of 3 are there? Okay? And those are combinations. And later I'll show you how to find all these combinations. So let me come up with another example. Okay? So let me have this set 1, 2, 1, 2, and 3. Okay? And we have to choose groups of 2 from it. Groups of 2. 1 and 2 can be a group. 2 and 3 can be a group. And 1 and 3 can be a group. So there's 3 groups, 3 combinations, right? But if I were to give a set of 100 numerals, you will not be able to count right. So there's another strategy, similar to the one I used to solve permutations that I'm going to give later on in the slides. So now we will just review the definition and learn more about examples. Okay, so does anybody want to take notes on these definitions? Okay. Does anybody want to take notes on the... Okay. So one yes and one no. And does anybody else want to take notes? Okay. Taylor says no. Okay, anybody else? Okay, I don't think, yeah, majority wins, but someone still wants to take notes, so I'll just go over briefly, okay? Just go over it briefly. Okay, and let's move on to the next slide and take notes on that. And when you're taking notes, it's not necessarily about going word for word with my definition. You might want to include some examples too to help you really understand. Okay, sometimes the word definition is a bit confusing. Okay, so now I'm going to introduce factorial. And this will be used when solving permutations and combinations. So the definition of factorial is the product of an integer and all the integers below it, excluding 0. And the factorial symbol is denoted as an exclamation mark. And an example of factorial is, let's see, 4 factorial right here is 4, and that's the specific integer that's being that has a factorial sign, and then all the integers below it, right? Excluding 0, so that'd be 3, 2, and 1, and then you multiply all of them together. What you get is 24. And let's try another one. Let's see, 5 factorial equals what? Do you guys know how to solve that? 5 factorial. So you can write in the chat what 5 factorial is. Okay, 120. Yes. Yeah, 120. Very good. Yes, very good. It is 120. And these early factorials, let's say 1 factorial, 2 factorial, 3 factorial, all the way to 6 or 7 factorial, you want to remember those, okay? You want to remember those because those are the ones that you're going to use most. So 1 factorial equals 1 because there's no integers below it. And then 2 factorial equals 2, right? And 3 factorial equals 6, 4 factorial equals 24, 5 factorial equals 120, and so on. You can figure out 6 and 7 factorial by just multiplying, okay? And these, you want to remember these basic factorials, okay? Those bigger ones, say like 200 factorial, that's way too big. You can't calculate that even on the calculator. And usually you can simplify these big factorials. And then once the final result is out, it turns out to be simplified to these kind of small ones. Okay, so you only need to memorize the small factorials. Don't try to even remember the big ones because you won't use them very often. Okay? And now I'm going to move on to how to solve permutation. Okay, so let's see. First, I'm going to give you a question. Remember, we have to have a set of numbers and perform and solve all the permutations of that set. So I'm going to give you this set, 1, 2, and 3. That's very basic set, okay? Only 3 symbols or numerals. And without me telling you how to solve the permutations, try to do this mentally, okay? Try to do this mentally before I even show you how to solve permutations, okay? Okay, yes. Some people got 3 factorial, some people got 6. 3 factorial equals 6, right? So 6 or 3 factorial is correct. And how do we get this 3 factorial? Well, if you're given a very basic set of this, let's see, how many numerals are in this? There's 1, 2, and 3. There's obviously 3 objects in this set, right? And let's say the number of objects in that set equals x. Okay? And then, how to solve it? You just do x factorial, okay? So if you're given a very basic set, right? Let's say n, okay? N can denote how many objects in this set. You're given a basic set. Let's say 1, 2, all the way. Okay. All the way to 1000. Then what will it be? 1000 factorial, right? That's how many objects are in the set. And that's how you solve. Let's say 4 objects in the set would be 4 factorial, right? It'd be 4 factorial, and that is 24, okay? So does everybody understand how to solve permutations? And these are very basic ones. Okay. Michael, you asked. Yes, I do have the review 1 and 2 slides. And I can put them in the group chat if you want. Okay, so later I will go to the group chat and probably post those. Okay. And now let's go back to here. In permutations is very basic when you're dealing with these sets. Later on, I'll introduce a different kind of problem. Then you have to use something called the box method. Okay? So now let's move on to how to solve combinations. And this one, a bit complicated, okay? So this is the combination formula. A bit complicated. Okay? When we solved permutations, we only used n factorial, right? But now we have to use this whole factorial. Now we have to use all these factorials and all these variables and this load of numbers and variables to form this big formula, right? Okay, so now I'll show you how to use this formula. So this C, this just stands for combination, so that can be ignored. You don't want to, that doesn't have anything to do. It's just that's the way you write the combination, okay? So now you have to pay attention to the N and the R, okay? So what is the R? what is the n? The n is all the objects in the set. All the objects in the set. Okay? And the R is remember in the combination definition, I said you have to pick like groups of 3 or groups of 2 from this whole big set, right? The R is the number of objects in the selection that you're picking from the big set, okay? Okay, so the number of objects in the selection from the set. Okay? So that is what R stands for, and that is what N stands for. And then, you see, we get this big formula. So N factorial is on the top, divided by the quantity of N minus R factorial, then multiplied by R factorial. Okay, so basically when you're solving combinations, let's say how many groups of 3 objects can you select from 8 objects? And then you just plug in the numbers into this formula and it'll always work. All you need to know is the formula. But just knowing the formula is not enough. We have to understand and we have to think deeper of how the formula works, why the formula works. Okay? So let me explain. Let's explain it in an example. But first, does everybody understand this combination formula and what N and R stands for? Does everybody understand? Yes or no? Okay. So then I wrote the definitions of N and R here, so you can take notes of that. So N is all the objects in this set. Okay? All the objects. Let me give an example set. Let's say 3 and 2 and 1. Okay? That's an example set. All the objects in the set. The number of objects in the set. Okay, not all of the objects. The number of objects. Got that wrong. Number of all objects in the set. That'd be 3, right? Be 3. There's total 3 objects in the set, right? And then we have the R, which is the number of objects in the selection from the set. So let's say we have this problem. And the problem is asking you how many groups of 2 can be selected from this set of 3 numerals. Well, you have to select groups of 2, right? So the number of objects in the selection would be R. And that would be 2. Okay? Does everybody understand now? And you can also copy the definitions. Okay, so now we'll practice this formula. So now the number of all the objects in a set would be 3, right? So 3 factorial over what is n? 3 again, minus r, and r is 2. And then factorial times r factorial, which is 2 factorial. Okay, and now we get 3 factorial over 1 factorial multiplied by 2 factorial. Now, how do we get this? How do we get this? So 3 factorial is the permutation of every single object, okay? All the objects in the set. So this is the permutation of all the objects. But permutation involves order, right? So you're basically ordering the objects. But remember, combinations order doesn't matter in combinations. And okay? And you are selecting 2 objects in this set, right? So here's this 2. And I'll explain why I'm emphasizing on these. And here's the 1. Now tell me, what is 3 minus 2? It's 1, right? Well, if you're supposed to take 2 objects from the set of 3 objects, there's 1 left over, always, in every situation, right? So in that situation, you don't want that 1. So you divide by it because it's not included in all those groups. It's not included, okay? And you can, so let's see. So in every scenario, let's say you group 1 and 2 together, there's still 1 missing, right? Because there's only groups of 2, not 3. And you don't want that extra 1, so you divide by it, don't multiply it, okay? But why is this factorial? Why not just divide by 1? Factorial is because factorial is basically the permutation of it. And with factorial, order matters, but in combination, order does not matter. So that's why we divide by 1 factorial, not 1, because we don't want the factorial. We divide by the factorial, so the order is gone, okay? And then the same is with 2. Once we don't want this extra 1, so that's out of the picture. But we still have this 2. And let's say we group 1 and 2 together. In this group, 2 and 1 can switch. They can permutate themselves. But we don't want that permutation. We don't want that. So that's why we're not just dividing by 2, we're dividing by 2 factorial. We're dividing the factorial because basically now we're canceling out the order in it. So in the groups, they can't permutate themselves. In the combination formula, the definition, I said that in combinations, the order does not matter, okay? Okay, somehow I can't get these slides. Oh, there we go. Okay. So let's see. So to further your understanding, let's try another example. Okay, this time we're dealing with just 1, 2, 3, and 4. And please can you please use the combination formula to solve this problem, okay? Can you please use the combination formula to solve this problem? And in this, please pick out groups of 3. No, let's say 2. how many groups of 2 can be picked out from this set of 4 objects? So groups of 2. Groups of 2. Okay? So please solve this problem. Yes. Sets of 2. Yes. So Ray Shan got 6, and Taylor got 2. Michael got 6, and William got 6. So let me go over it now. And what is the number of all the objects in the set? That'd be n. There's obviously 4 objects in the set, right? So 4 factorial is on the top. We're using this formula right here. And then we divide by n minus r. Now, what is the number of objects in the selection from the set? That'd be 2, right? So n minus r would basically be 4 minus 2, right? And then we get this. 4 minus 2 factorial multiplied by another 2 factorial. And then this bottom simplifies to 2 factorial times 2 factorial, which is 4. And then the top simplifies to 4 factorial equals 24. And 24 divided by 4, and you know what that is? That is 6, right? So a lot of you got 6. So great job on that, okay? That seems like you understand. So now let's practice permutations, and then later on we'll be practicing with combinations. Okay, so how many permutations are there of A, B, and C? Okay, so this is our first problem, and please do this on your own. And when you're done, please put your answer in the chat box. Yes, 6. Most people got 6. Okay. There are some 3s in there. So, okay. So now let me walk you through this. So basically our set is A, B, and C, right? That's our set. And how many objects are in that set? What is the number of total objects in that set? Well, that would be 3, right? So we have 3 factorial. That's all it is. Okay, just 3 factorial. Because we're dealing with permutations here, and 3 factorial is all you need. Okay? So to the next problem. Number 2 is how many 4-digit numbers are there? How many 4-digit numbers? Okay? So this one we haven't learned yet. You can't solve this with just a single factorial. With this one, we need to use something called the box method. Okay? So there are 4 digits. 4 digits. So we have 4 boxes. Okay? 4 places. And So we have let's say, a very common 4-digit number. 1,000, right? 2,000, 3,000, something like that. And we can use the digits 0 from 9 here. So we have 10 digits in total to choose from. 10 digits in total to choose from. And the first digit, okay? So the starting digit, let's say 2,000. The starting digit would be 2, okay? The thousandths place. Thousandths place, we have 10 digits to choose from, right? No, actually, we have 9, not 10. Why? Because we can't include 0, right? We can't start a 4-digit number with 0. So we have 9 possibilities. So these are the possibilities. Okay, put the possibilities of the digits in these boxes. Okay, and the next the hundredth digit, we can use 0, right? So that's a 10. And same for the tens place and the ones place, unit place. Okay, so after you're done with that, you just multiply all these boxes together. And in this case, we get 9,000. Okay, so for those students who have already been to my class, then you know the box method. Yes. Okay, so now we try something harder. Okay, number 3 is, in how many ways can 3 Americans, 4 Chinese, 2 Japanese, and 4 Canadians arrange themselves in a row of seats if each of the same nationality have to sit together? So please try to do this problem. In how many ways can 3 Americans, 4 Chinese, 2 Japanese, and 4 Canadians arrange themselves in a row of seats such that each of the same nationality have to sit together? Okay, so please solve this problem and put it in the chat box for me to see. Okay, 24. So 2 people said 24. Any more people? Okay. So, Carney, you have been getting a lot of answers correct. So I assume you should know this one. Carney, do you have an answer? Or Kiki, what about you? Okay, Carney says they can interchange in their own nationality. Okay? So still 4 factorial, Carney. Does anyone have a different answer than 4 factorial? And now I'll tell you this. Every answer that I have received so far is incorrect. So 4 factorial isn't the correct answer. Okay. 4 factorial isn't the answer. So I'll give you some time to try and solve this. Okay, so now I'll walk you through this. So many of you think that this is a set, right? This is a set, and you just what is the number of objects in that set? And we can just do 4 factorial, right? Right? Many of you think that, but this is actually much more complicated than just 4 factorial. Yes, 4 factorial is a part of that. It is a part of it. But have you noticed that within each nationality, they can permutate themselves, right? In the Americans, they can permutate themselves. In the Chinese, they can permutate themselves. And then overall, all the nationalities can permutate, okay? So Americans, they can permutate within the same nationality, within the Americans, okay? They can permutate. So that'd be 3 factorial for the Americans. And then Chinese, 4 factorial again. Japanese, you have 2 factorial. And then Canadians, you have 4 factorial. Okay, so it's not just an overall 4 factorial because within each nationality, they can permutate themselves. So we have to count those permutations in also. And now if you just multiply everything, 24 times 6 times 24 times 2 times 24. Okay, so that is the result. Okay, quite a big number. So let's see. It would be 165,888. Okay, so that would be our answer. Okay. So here we have it. So now let's practice combinations, okay? We don't have much time. Now combinations. So let's practice this. So number 1 of combinations would be how many groups of 3 can you select from 4 objects? How many groups of 3 can you select from 4 objects? So please use the combination formula and try to use this, okay? To solve this. Also, when you're done, you can put in the chat for me to see. Okay, so Kiki says 4 groups of 3. Okay, very fast answer. Good job, Kiki. And anyone else? And Steven says 12. Carney says 4 factorial divided by 1 factorial times 3 factorial. Exactly correct, Carney. Okay, now you just have to solve all those factorials. So I'll leave this problem up for a few moments, and you can try to solve this on your own. Okay, so a lot of 4s. And I am pretty sure 4 is correct. Okay? So now I'm going to walk you through on how you get this answer. So our set of 4 objects, okay? So let's say the 4 objects are 1, 2, 3, and 4. It doesn't specify what kind of objects are in that set, but let's just say it's 1, 2, 3, 4. And what is the number of all the objects in that set? It's obviously 4, right? It already says in here. And now we can just substitute in those numbers to our combination formula. Remember, right here should be n minus r factorial times r factorial. And what is 4 minus 3? Okay, we're selecting groups of 3 from 4 objects, so it should be 4 minus 3, and that would be 1 factorial, okay? And then multiply by r factorial, and then r, you know what that is. That is 3, correct? And you get this. This is the combination formula, okay? And then you can simplify this. On top is 24 because 4 factorial is 24. And then on the bottom, 1 factorial is 1. And then 3 factorial would be 6. 1 times 6 on the bottom. And this would be 24 divided by 6, which would be 4. So those who got 4, congratulations. Okay. So now let us move on to the next problem. So this is our next problem. In a group of 10 people, 2 people will receive prizes. In how many ways can the prizes be distributed? In how many ways can the prizes be distributed? Okay? So please solve this problem. I'll give you a few minutes. And put your answer in the chat box. Okay. So I'll give you a few more moments. Let me check the answers. Carney says, I think Stevens is the first one. Well, Stevens says 45, and Carney says 252, and Kiki also says 45. Michael also says 45. So the only disagreement to 45 is Carney's 252. So who will be correct? Okay, any more different answers? Does anyone have different answers? Okay, Taylor says 20. So 20, 252, and there's 45. Okay. And any more answers? Okay. So in this problem, try to show how did you solve this problem, okay? Show your work. So this problem, when you're answering, show your work, okay? Show the formula and how you did it, okay? So please show the formula on how you got the answer, okay? Okay. So Carney says it is 10 factorial divided by 8 factorial times 2 factorial. Okay, so very good. Now I'm going to walk you through it. In a group of 10 people, right? So all the number of all the objects in the set would be 10, right? And then we can do 10 factorial on the top of that equation, divided by 10 minus r, which is what is the number of objects in the selection we're taking from the set. And that'd be 2, right? A group of 2, okay? Right here, group of 2. And you just do that, factorial times another 2 factorial. And this would equal to 10 factorial divided by 8 factorial times 2 factorial. Okay? Very good. And 10 factorial, let's see, I have my calculator out. So let me punch that in real quick. 10 factorial would be 3,628,800, okay? Divided by 8 factorial, which is another big number, and then 2 factorial, which is probably 45. And now, how many of you actually put in the numbers into the calculator, like me, and manually put in the numbers and I just divided it in the calculator? How many of you use the calculator? So I assume that many of you use the calculator. Okay, but there is another way. Okay, so without even using the calculator, remember 10 factorial is a relatively big factorial, okay? So pretty big number, right? And remember where I said I could simplify, right? We can simplify those factorials. And what is 10 factorial? It's 1 times 2 times 3 all the way to 10, right? And what is 8 factorial? 1 times 2 times 3 times 4 all the way to 8, right? Okay. And you have to notice that in 8 factorial, 1 times 2 times 3 all the way to 8 is in 10 factorial. Because 10 factorial is basically 8 factorial times 9 times 10, right? Please observe. 10 factorial is this: 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. And then observe. A factorial. 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. You see? This section right here. All the same, right? It's just 9 and 10 are extra. And you see, we're dividing 8 factorial from 10 factorial, right? And when you divide all these numbers, this cancels out. Both of these cancel out. And what do you have left? 9 times 10, right? So you can cancel this out. You can cancel most of this out, and you don't have to manually punch in those numbers in the calculator, okay? So you divide this, cancel out. And then you get 90 divided by 2. And then you get 45, correct? Yes. Okay. Good. So now we have the last problem. Number 3 is how many committees of 5 can you select from 8 people? Okay? How many committees of 5 can you select from 8 people? So please solve this problem. Okay. Put your answers in the chat box when you're done. Oh, okay. So some people were asking how to what does factorial mean, right? So I assume that you guys came late and missed the factorial definition. So I'll explain factorial again. Okay. So factorial, let's go back to the factorial slide. It is the product of an integer and all the integers below it, excluding 0. And it is denoted with an exclamation mark. So basically 4 factorial would be 1 times 2 times 3 times 4, or 4 times 3 times 2 times 1, okay? And 5 factorial would be 1 times 2 times 3 times 4 times 5. And so on with 6 factorial, the same. Okay? That very brief explanation of factorial. So now let's go back to the problem. Okay, so people said 56 and 112. And there's also a 168. Okay. Oh, I will explain it now. So there are 8 people. So in total, right? 8 people. It's the number of all the people in the set, correct? And then the 8 factorial on top, divided by 8 minus 5, because 5 is the number of objects in the selection we're taking from the set. Then factorial times another 5 factorial. So basically it would be equal to 8 factorial divided by 3 factorial times 5 factorial. Remember, we can simplify, right? We can simplify. 8 factorial equals 5 factorial times 6 times 7 times 8, correct? And then we can cancel these out, right? And then we can cancel another pair out. Because 3 factorial, we can cancel that out with 6. Why? Because 3 factorial equals 6. And then we get left with 7 times 8 divided by 1, which simplifies to 56. Okay? And that is the correct answer. 56 committees of 5. Okay. Yes. Very good. So that marks the end of our class. So thank you everybody for listening, and this will be the last of my classes, but maybe in the next summer break I will put a class for 7th and 8th grade math. But this will be the end of 5th and 6th grade math. So thank you everybody for listening, and goodbye. Okay. Thank you, everybody.